Let us see once again what is write through and write back. In write through technique, both main memory and cache memory locations will get simultaneously updated. Okay, both will get simultaneously updated. Okay, so but the process will be slow because at a time writing will have to be performed in both cache memory and main memory, because simultaneous access will always be slower. But write back will be faster because at a stretch only one memory module will get updated. Either it could be cache memory or main memory. Okay, so initially cache will get updated, finally main memory will be written back, so during which the process will be very faster. Okay, now let us talk something about cache initialization. What do you mean by cache initialization? Let us say this is my cache memory. Okay, this is the cache. Now when you switch off the computer system, there won't be anything in cache memory, right? There won't be anything in the cache memory. When a system is switched on again, CPU will be ready to access the data. Anyhow, either it is switched on or during the process, or system is about to get shut down. Initially, CPU will send the address references only to the cache memory, right? Initially, you know that the cache is completely empty. Cache cannot provide any information to the CPU. So, if at all the CPU has to get the data out of the cache memory, first of all, cache must be initialized. What is this initialization process? Let us see. Okay. Now, these are the words within the cache. These are the words within the cache. All of these words will have something called a valid digit, a valid bit. Okay, you can see that all the words are associated to one digit called valid bit. Okay, now the moment CPU is switched on, this valid digit will be clear to 0, 0, 0, 0, 0, 0, meaning the data in that word is not valid at all. What is not valid? You can find out anything here, some garbage value. It is only a garbage value. It is not transferred from main memory. The data becomes valid only when it gets transferred from main memory. So for that reason, the moment the computer system switches on, initially the system is going to clear all the valid digits to 0. Okay, when CPU sends an address reference to cache memory, the corresponding location will get located, in which first the CPU is going to check for this valid digit. If the valid digit is equal to 0, that means that the data under that specific location is not valid at all. So then CPU is not going to perform a search within the cache. Then it goes to the main memory. Okay, it is going to directly read it from the main memory. Then the word will get transferred to the cache memory. At that time, this valid digit will be set to 1. That is what the valid digit is all about. Initially, the valid digit will be clear to 0. The moment you switch on the system, the valid digit will be clear to 0. When an address reference has been sent, this address will be initially located in the cache, because for the faster access. Okay, but anyhow, CPU is going to watch the valid digit. When this valid digit is equal to 0, which means that the corresponding data on that specific location is not valid at all. Okay, so when again it will get access from main memory. During the access from the main memory, the data should also be transferred to that location in the cache memory. At that time, the valid digit will be set to 1, saying that the corresponding data in that specific location is valid. So whenever CPU want to access this information again, CPU can read it looking at the valid digit, because the valid digit is saying that this is 1, so that the data is valid. This is all about cache initialization.